morning student. I Kinnari Dave from Ambi Patel English Medium School welcomes you all for part 2 of Standard 11 Unit 4 Chemical Bonding and Molecular Structure. Student, in the part 1, that is introductory session, we have studied there is some force of attraction and that forms the molecule, compound and the mixture. Means atom is having their independent existence, but due to the high energy they combine with one another and they form the molecule. And yes, previous video we have stopped at that one example, that is the example of BeCl2, barium chloride. And in that it does not follow the octet rule. We have studied about the octet rule also. What is the valence electron and what is the valency of the particular element, that we have studied from the Lewis dot structure. So Covalent-Lewis approach we have studied in the part 1. Now in that part 2 we are going to start this part 2 from where exactly we end, that is the BeCl2 does not follow the octet rule. So there are some of the molecule and the compound which does not follow the octet rule. So we'll start with that. Just student, look at the board everyone. Now here the unit 4 chemical bonding and molecular structure part 2. Here we'll start exception of octet rule. There are some element central atom when they forms the molecule or when they forms the compound. The central atom, while we are drawing the Lewis dot structure, it does not obey that central atom. Either they were having the more number of electron or maybe they were having the less number of electron, or sometimes it is a electron sufficient element. So here we are going to study about the not electron sufficient element with the center atom, but we are going to study other 3 options. So the first option which I have written, that is electron deficient. Means here we are going to study about the compound by drawing the Lewis dot structure, which central atom either having the more number of electron than the octet rule, but then also they are comes under the category of stable compound. Some are having the less number of electron, which I am talking about only the central atom, student, but they also comes in the under the name of the stable compound. So first of all we'll start electron deficient. Here I have taken the example BeCl2, which in the previous video was the last topic. As what is the valency of the beryllium? Be means beryllium. As you know that hydrogen, helium, lithium and beryllium. Beryllium is having the 4 atomic number, means 4 atomic number means beryllium possesses the 2 valence electron. So here I have drawn the valence electron of beryllium by putting the cross over the beryllium. And as you know, the chlorine is a group 17 halogen element which is having group 17. 17 means 7 number of valence electron. Minus करके हम इसका आंसर निकाल सकते हैं. So this is the 7 valence electron which I have drawn by putting the dot. So you can see student, chlorine 1, 2, 3, 4, 5, 6 and 7 electrons. Same way here chlorine 1, 2, 3, 4, 5, 6 and 7 electron for this chlorine. And the beryllium is having this 2 cross mark, that are the 2 electrons. Now here the chlorine is going to follow the octet rule. The same way here the chlorine also follows the octet rule. But you can see the beryllium that I have made encircle over there. So here 2 electron and here 2 electrons. So beryllium is having only and only the 4 electron. But then also it is a stable compound, student. Now we'll go with the one more example for the electron deficient. Here I have taken the boron chloride BCl3. Here I have taken the example boron. Boron is with the 5 atomic number. 5 atomic number means it is having the 3 valence electron, which I have shown by putting the cross mark. So boron 1, 2 and 3, and the same way chlorine is with the 7 number of valence electron. So by putting the 7 electron by putting dot. You can see here also, student, this chlorine is also having the 8 number of electron. This also follows the octet rule completely. This also follows the octet rule completely. But you can see, student, about the boron. What is the status of boron? Here 1, 2, 3, 4, 5 and 6. Boron is having only the 6 electron. So central atom is considered as an electron deficient. Now we'll go with the electron precise. Means the central atom is having more number of electron, or we can say that electron rich element. Here I have taken the example of very well known example, student, this PCl5, phosphorus pentachloride. So phosphorus, what is the phosphorus comes under the group nitrogen group family. So nitrogen is having, as you know, it is having the 5 number of valence electrons. So the phosphorus also with the 5 number of valence electron, which I have drawn by putting the cross mark. So 1, 2, 3, 4 and 5, and as usual chlorine is having the 7 number of valence electron. So you can see here, student, this chlorine follows the octet rule. This chlorine also follows the octet rule. This also with the 8 number of electron. This is also 8 number of electron, and the same way 5th chlorine is also following the octet rule by fulfilling its stable structure. But just look at the phosphorus, student. Look at the phosphorus. What do you observe for the phosphorus, student? 5 electron of itself and 5 electron of chlorine. 5 chlorine, each 1 electron. So here you can see 2 to 4 to 6 to 8 and to 10 electron. Phosphorus central atom is with the 10 number of electron. Then also this phosphorus pentachloride is a stable compound. So these are the exceptions, student, which does not follow the octet rule, but they are coming under the name of the stable compound. Then another example I have drawn over here, IF7. Iodine and fluorine both are of the same family members, means both are of the halogen family, iodine and fluorine. Fluorine, chlorine, bromine and iodine. So this both are of the same family member. So both is having this 7 number of valence electron. So you can see, student, each fluorine is following the octet rule, but iodine is having the 7 number of its own electron, and the 7 electron, this 1 electron from each of the fluorine side possessing the 7 electron. So 7 electron of itself, iodine, and 1 electron from each of the fluorine. That's why here iodine is with the 14 number of electron. Think, children, here 2, 4, 6, 8, 10, 12 and 14. So iodine is having the 14 number of electron, but it is also the exception with the stable compound. Now we'll go with the next one, which is having the central atom is possessing the odd number of electrons, student. And here also, as you know, the नाइट्रोजन ऑक्साइड्स के बारे में आपको पता है, नाइट्रोजन के बहुत सारे ऑक्साइड्स प्रेजेंट है. So from that I have taken only one example, but then also for your practice you can draw, student, other nitrogen oxides also. Nitrogen dioxide example I have taken, but you can just go for the nitric oxide, nitrogen trioxide, dinitrogen pentoxide, N2O3, N2O5. Number of nitrogen oxides you can take for the example for your satisfaction, students. So now just look at the board. Here I have given the nitrogen dioxide, NO2. Nitrogen is having the 7 electrons, so the 5 electrons are present in their valence shell. So here the valence electron I have drawn 1, 2, 3, 4 and 5 by putting the cross. And the oxygen is the next member group of the nitrogen. So oxygen is having the 8 number of electron. So Z of the oxygen is 8, means oxygen is having the 6th number of valence electron, which I have drawn by putting the dot over the oxygen. So now you can see, student, this oxygen 3, 4, 5, 6, 7 and 8. Oxygen is also having completing their own octet. This dot I can put over here. So here, and from this one bond I can put over the here. So here you can see that 4, 5, 6, 7 and 8 oxygen is following the octet rule. The same way this oxygen 2, 3, 4, 5, 6, 7 and 8. So here you can see, student, but you just think about the nitrogen. 1, 2, 3, 4, 5, 6, 7, 8 and this 9 electron. You can see, student, here you can see with the nitrogen is having the 9 electron, 4 from this side, 4 from this side, so 4 and 4, 8 and 1 is 9. But oxygen is going to complete their octet. So here the nitrogen is with the odd number of electrons. Same way you can draw the example for the NO also. Here one more example I have taken, that is Chloros Acid, ClO2. ClO2 as chlorine 7 number of valence electron and oxygen 6 number of valence electron. So the chlorine oxygen I have drawn with the cross mark and oxygen electron by putting the dot. You can see, student, oxygen with the 4, 5, 6, 7 and 8 electron. Here also oxygen 4, 5, 6, 7 and 8 electron. But you can see, student, what about the chlorine condition? Chlorine is 4 and 4, 8, 8 and 2, 10 and 1, 11. So this is also the central atom is having the odd number of electron. So this you can understand, this all are the exception of the octet rule. Now this all is known as the chemical bond. So other than this also, this we are going to study about the ionic bond. You know about the covalent bond also, and you know about the coordinate bond also. Even as you know, the H bond, hydrogen is also coming under the category of the bond. It is a force of attraction, because bond is nothing but it is a force of attraction. So the chemical bond, one more chemical bond which is a very weak bond, but it is also there, van der Waals force of attraction. Van der Waals force of attraction, that is a polar एंड नॉन पोलर के बीच में होता है, जिसे हम लंडन फोर्स कह सकते हैं, स्टूडेंट. दैट यू विल स्टडी इन द you have already studied maybe, student, in the chapter number 3. So here we are going to just identify the classification of the chemical bond. The first of all, as I said, the van der Waals force, or van der Waals force, the energy, it is very weak force. That's why, as I said, the energy is below 10 kilojoule per mole. Means for the formation of these forces, very less energy is required, less than 10 kilojoule per mole. Then H bond is stronger than the van der Waals force. So here the energy required is 10 to 42 kilojoule per mole, means it is a little stronger than the van der Waals force. And the higher the energy, means nearby 200 kilojoule per mole, above 42 to nearby 200 kilojoule per mole energy is required for the formation of as ionic bond. You know that there is a cation and anion. Then the another one, it is a covalent bond. In that covalent bond, as you know, it is having the sum of the sharing of the electron. Third one, it is a coordinate bond. In the coordinate bond, one atom is shared with the both, means one atom is only giving, he is not accepting, he is not ready to accept from the other atom. So that is a coordinate bond. And the last one, it is a metallic bond. So this all now we are going to study. Metallic bond you are going to study in the standard 12. Just now we are going to study about the ionic bond and the covalent bond. So student, now what is the ionic bond? As the ionic bond means what? The transfer of electron. Complete the electron will be transferred from group 1A to 3A element to the group 5th A to 7th A element, student. That is known as the ionic bond. The another bond, as I said, that is known as the covalent bond. Covalent bond means what, student? The sharing of the electron. You also require one electron or two electron to complete the octet structure. Same way, I also needy for the 2 electron. So we all will we both will just share the electron, as student you are sharing your nastas during the recess time. Same way here the sharing of the electron is known as the covalent bond. And the third one, as I said, the coordinate bond. Coordinate bond means what? Any one atom out of the 2 or 3 atom which combines and forms the molecule or a compound. Only one is donating or sharing the electron to others. It does not require any of the electron from the any other side. That is known as the coordinate bond. So student, just look at the simple definition. Ionic bond means transfer of electron. Ionic bond is also known as electrovalent bond. Why it is known as electrovalent bond? Because in ionic bond, one electron from the sodium will be given to the chlorine. So one is positive ion and one is negative ion. They are combined with electrostatic force. So that's why this bond is also known as electrovalent bond. This we are now understanding that also, student, don't worry. After this topic finish, after the definition of this all 3 bonds finish, I'm going to explain you about the ionic bond also. Then the next one is a covalent bond, simply the sharing of electron. And as a coordinate bond means electron is contributed by only one atom. As I said, only one atom is ready. Yes, I am a very good donor. मेरे पास है, लेके जाओ आप, है ना? So only the one atom is contributing its electron with the other atom which going to take part for the formation of the molecule or a compound. NF3, the very good example for this NF3, NH3, that is the example of coordinate bond, students. So now we'll just start the ionic bond. Ionic bond, as I said, it is having the electrostatic force of attraction between cation and anion. Cation कहाँ से बनेगा? As you know, the alkali metal group 1A, alkaline earth metal group 2A and group 3A element are always having the capacity to donate the electron, and that's why all the metal elements forms the positive charge. So here we are just taking the example of very well known example, and you have studied in the standard 10 also, its crystal structure also you have studied. So we'll take the example for Na. So sodium is donating its electron which is there in that valence shell, and sodium become the Na plus. Now this one electron which is donated by the sodium is the requirement of the chlorine, because as you know the chlorine is having the 7 number of valence electron in its outermost shell or a valence shell. So this electron which is donated by the sodium will be accepted by chlorine. So here you are writing Cl plus electron, and this becomes Cl minus. So here the Na plus and Cl minus forms NaCl, that is your ionic bond. One more example we are just taking for this, that we are going to take from the next, that is sodium magnesium. As you know, magnesium, atomic number of magnesium is 12. So to attain the stable configuration, the nearby noble gas. So 10 is the nearby noble gas of this magnesium also. Like sodium wants to lose the 1 electron, but magnesium atomic number is 12. So to attain the neons configuration, magnesium has to leave the 2 electrons. So magnesium will donate the 2 electron and forms Mg plus ion plus 2 electron. Same way, now here as you know the chlorine require only 1 electron. So now what happens? Magnesium will call the 2 chlorine from both the sides, and magnesium give 1 electron to this chlorine and another electron to this chlorine. So here the 2 chlorine comes from both the side, or we can just draw the structure for this. So here this magnesium, it is donated 1 electron to this and 1 electron to this, and here you have a chlorine. So 1, 2, 3, 4, 5, 6 and 7. Same way here 1, 2, 3, 4, 5, 6 and 7. So you can see student here, this way chlorine has completed its octate and magnesium has donated its electron. So now here how to write the formula for this? As I said, this ionic compound have only the empirical formula. They don't have the molecular formula, student. So this is a very important for that. So Mg has given the 2 electron. So if you are writing this Mg plus 2, correct? Further writing the formula, always cation is on your right hand side. Cation is on your right hand side and anion is on your left hand side. So here the anion is chlorine and chlorine is having the -1 charge. So here I have just given you this same way how to write this formula. A2B1, in place of any of the element symbol I have taken A and B. So A2 and B1. So now what will you do? Here magnesium is with the 2 charge and chlorine is with the 1 charge. So this already you have studied, student, in the 9th standard. Yes, I know. But as just to memorize, to revise, Hannah. So it is very easy to remember. So here this is the cross way, and the formula for this compound is known as MgCl2. MgCl2. The same way here I had explained you, that is known as AB2, means A and B as a symbol of element I have taken. So this is the way you can write the formula for the ionic compound. Now student, what is the condition required for formation of the ionic bond? ऐसे तो बन नहीं जाएगा. If you do not require any of the electron, and if I am going to try to give you the electron, just take it, then are you ready to take the electron from me? No student. So the first condition is required. Donor and acceptor both are ready to give and take the electron. Donor is ready to give the electron and acceptor is ready to take the electron. So we'll start the condition which is required for the formation of ionic bond. I'm just rubbing this about topic student. Then I can explain you the condition for the same. As I said, if sodium wants to give the electron, but sodium tries to give the electron suppose to the magnesium, then can magnesium will take the electron? Can magnesium accept the electron student? No, because magnesium does not require the electron. So the first condition is ionization enthalpy. What is ionization enthalpy? Ionization enthalpy means student the cation formation. If the electron donating capacity is more, then that energy is the ionization energy or ionization enthalpy. So ionization enthalpy, we can say that amount of energy required to remove an electron. Amount of energy required to remove an electron from the valence shell to the isolated gaseous atom. So cation कब बन सकता है? When the amount of energy is lower, means it is easily give the electron. अगर उसकी amount of energy high होगी तो वो easily electron donate नहीं कर पाएगा. So the first condition is ionization enthalpy is lower than more the tendency to form the cation. And what is ionization energy? Ionization enthalpy, student, if you want to write the definition, then you can write, but it is given in your textbook also, and you maybe have memorized also. But one more time, just I am dictating. Ionization enthalpy means the amount of energy required for an electron to form the isolated gaseous atom, remove the electron from its valence shell to form the isolated gaseous atom. So this is the first condition. The second condition, as another person is also ready to accept the electron, so that energy is known as electron gain enthalpy. इलेक्ट्रॉन लेने के लिए भी तो वो रेडी होना चाहिए. सो अगर आयोनाइजेशन एंथैल्पी कम है तो इलेक्ट्रॉन गेन एंथैल्पी क्या होगी? करेक्ट स्टूडेंट. इलेक्ट्रॉन गेन एंथैल्पी, आपकी लेने की क्षमता, आपकी लेने की कैपेसिटी ज्यादा होनी चाहिए. मोर यू अक्वायर्ड द इलेक्ट्रॉन इजीली you can form the easily negative ion. So here the ionization enthalpy के बाद में है electron gain enthalpy. The amount of energy released when the electron is added to the outermost shell, वो ready होना चाहिए, accept होना चाहिए. तो second is higher the delta Eg, means electron gain enthalpy, more is the tendency to form the negative ion. So negative ion formation कब होगा? जब उसकी लेने की कैपेसिटी ज्यादा होगी स्टूडेंट. सो हियर यू कैन सी द आयोनाइजेशन एनर्जी Na+ की सबसे ज्यादा होगी बिकॉज इट वांट्स टू लूज ओनली वन इलेक्ट्रॉन. Mg+2 की उससे थोड़ी सी कम होगी, उसके बाद Al+3 की होगी. सो दिस इज द formation of the ionization energy. And if the electron gain enthalpy we can see, then the fluorine is having the highest electron gain enthalpy because the fluorine is require only one electron to get the stable configuration. And the third one, it is also very important student, lattice energy or lattice enthalpy. Now actually what is lattice enthalpy? अब यहाँ से cation आता है, यहाँ से anion आता है. When they both move, they comes to the closer, there is electrostatic force between them. When they both comes to closer and then they tightly packed their atom amongst each other, between them other molecules. So what happens student? इस तरह से अगर वो फिक्स्ड होता है तो उस टाइम पे जो एनर्जी रिलीज होती है, जो एटम बना, जो नया आपका मॉलिक्यूल आयनिक बॉन्ड फॉर्मेशन हुआ, तो उस टाइम पे जो एनर्जी रिलीज हो रही है, दैट इज नोन एज योर लैटिस एंथैल्पी. So what is lattice enthalpy student? Lattice enthalpy is the energy release when 1 mole of crystal lattice is formed. Here I have written the definition student. Lattice enthalpy means amount of energy released when 1 mole of crystal lattice is formed. 1 Na+ and 1 Cl- मिलके एक क्रिस्टल बनाया और वो जब बॉन्ड फॉर्मेशन होता है, इलेक्ट्रोस्टैटिक फोर्स होता है उनके बीच में और उनकी अरेंजमेंट इस तरह से होती है जो आपको मालूम है. मतलब ये है आपका प्लस, तो यहाँ आया आपका माइनस, यहाँ भी आपके पास में है माइनस, यहाँ भी आपके पास में है माइनस, यहाँ भी आपके पास में है माइनस, और एक ये है आपके सामने की साइड में, क्योंकि ये क्रिस्टल 3 डायमेंशनल स्ट्रक्चर है, और एक जो है वो पीछे की साइड में है. सो 1 पॉजिटिव आयन सराउंडेड बाय 6 negative ion, and the same way 1 negative ion are surrounded by the 6 positive ion, which you have already studied in the standard 10. NaCl का structure आपको दिया गया था. So the same way, if I am going to explain you here, this is your negative ion surrounded by plus ion, plus ion, plus ion, plus ion. One is in the front and another is in the back. So this is the structure of cation and anion. So here when they all forms, here this formation occurs, the energy is released, and that is your lattice enthalpy. Now students, this lattice enthalpy is depends on what? Exactly, this lattice enthalpy is first of all depends on the magnitude of a charge, M plus ion या Z minus 2 ion. That is the magnitude of your charge. So the lattice energy is more when the size of cation is decreased. As I showed you here, Na plus, Mg plus 2, Al plus 3, Na plus की size, Mg plus 2 की size. So the size of cation decrease, the lattice enthalpy increase. The another condition for this is, suppose if we'll think the size of anion remains same, that way also if we'll think about the cation and anion, then the size of either of any one, the size of cation is always smaller than the size of anion. Size of cation is always smaller than the size of anion. So suppose this is the formation of anion Here you have a cation. This way, student, this arrangement is there. So suppose if we'll think the size of anion is same and cation size increase, because the already size of cation is very small. That also you have studied in the थर्ड चैप्टर कि पैरेंट एटम से कैटायन की साइज जो है वो छोटी होती है और पैरेंट एटम से एनायन की साइज जो है वो बड़ी होती है. दैट यू हैव ऑलरेडी स्टडीड इन द चैप्टर 3. सो विल कीप द साइज ऑफ एनायन सेम by increasing the size of cation, then also lattice enthalpy decrease. So this is the condition. And what is the exactly properties of this ionic bond or a crystal structure? First of all, we know that the crystal structure are very hard but brittle also, student. Why it is brittle? That just if you drop the piece of ice is a crystal structure. Same way salt, NaCl, that is also the crystal structure. If you drop it, it just breaks. Why it breaks? Why it is brittle? Here you can see that they were having the electrostatic force of attraction. This is your one layer, this is your another layer. If by pushing this first layer, then what happens, student? If you are pushing this first layer, then this layer moves towards this side. So वो थोड़ा सा इस तरह से आगे जाएगा. But this layer is as it is. So now what happens, student? This is the positive charge here and this comes the negative charge here. Now you can see that both the negative charge or maybe both the positive charge come closer, and as you know, the same charge repel each other. Correct? Same charge repel each other. By pushing the one layer, by just pushing the one layer, this layer moves, so there are the chances of two same charges to come closer, which gives the repulsion, and that's why ionic bond or ionic crystal are brittle. Same way melting point and boiling point. If we are talking about the melting point and boiling point, then melting point and boiling point are also very high, because here also the electrostatic force of attraction plays a very important role. So melting point, boiling point is high due to electrostatic force. Generally in the normal condition, means in the solid state, they are not a good conductor of heat and electricity. But when you dissolve this NaCl, this NaCl, Na plus and Cl minus will becomes in the free state. Means cation and anion forms in the free state. So they are behaving as a good conductor. So this crystal structure or ionic bond elements, compounds are the good conductor in that aqueous state and in molten state. And as you know, they are very good soluble in the water. Now why they are easily soluble in the water? Solubility is very high. So suppose if we'll think about the water molecule, as you know, the water molecule is having H plus and OH minus ion. So here Na is with the plus, and when you are dissolving it, here it is having the OH minus ion. Here you have a OH minus ion. So what happens, student? There is a force of attraction between this. Force of attraction between this, and that's why they try to soluble easily. Same way if you are talking about the Cl, Na plus and Cl minus, So H2O में से H plus is surrounded by Cl minus, and here also that forms the electrostatic force of attraction, and that's why they are very good soluble, or solubility is high of this compound. Hope so student, this topic is clear to you. In the next video I am going to explain you about the covalent bond, and from that we'll start about the VSEPR theory also. Thank you student, and it's your channel, so don't forget to subscribe it. Thank you so much student.